Got it. Yeah. So Larry Price and I are here today from Citizens Climate Lobby, which is a nonpartisan nonprofit organization dedicated to building political will for bipartisan climate solutions. And we want to talk today about the local impacts of climate change here in Arkansas, some of what's driving that, and then also look at this really cool tool called that's been created by Climate Interactive, which allows us to suggest possible climate solutions and to see how that would affect temperatures. So we'd like to start off just by sharing, feel free to jump in, climate impacts that you are already seeing and experiencing here in Arkansas.
Mm-hmm.
Feel free to jump in or put something in the chat.
Yes, we're pretty informal and we've got just a few people, so you can jump in and be fine. Or if you prefer the chat, that's fine.
Well,
Okay.
Go ahead, Katie. Oh, Katie wrote tons of snow.
Yeah, that's a good one.
I was just going to say, in February, yeah, we had like 18 inches. So that was crazy for Central Arkansas.
Mm-hmm.
Right. And Jeannie, that was a great conversation before we actually got started. And that reminds me that I do actually want to thank you so much for having us here, and thank the library system as well for doing this whole Earth Month series, because it's so important that we're talking about climate change and talking about conservation and taking care of the Earth.
Mm-hmm. Yep.
Well, here's another one, unusual planting season in agriculture as well, from Katie.
Mm-hmm. We've had roads wash out, literally wash out. 2 years ago, took them forever to fix it, and the roads now need a lot of work. There's a lot of washout, and in Northwest Arkansas, they closed down two highways, and one of them washed out. So yeah, that's 7.5 inches of rain in a few hours is just something. And yeah, but my gardening is really stressed because the weather, really has changed. The planting season is longer and hotter. Yeah.
It is. Yes.
Mm-hmm.
Larry, do you want to switch to showing some of your slides since we've had everybody?
Okay, let me show you here about some things about Arkansas. Okay, can everybody see that now?
Yeah.
Got it.
Okay, yeah, okay. Yeah, we're just going to kind of center on Arkansas, but I'm going to define a little bit about climate change and its causes. And these are a couple of little sayings I like to watch. This is Robert Swan. He was a polar explorer, and of course he would know about climate change. He says the greatest threat to our planet is a belief that someone else will save it. Someone else will save it. And Joan Baez said, "Action is the antidote to despair." I guess y'all are old enough to know who Joan Baez are, aren't you?
Yep.
I would expect so, yeah. Okay. Climate change has been around a long time. The idea, the concept of it started in 1856 when Eunice Foote, who's one of the first major female scientists, she suggested that rising CO2 levels might somehow result in global warming in the year 1856. Momentum was gathered in the 1880s, and by the late 50s, we really began to realize that it was a problem. And that's in 57, Keeling established the CO2 Observatory in Mauna Loa, which I'll talk about in a minute, but that was 1957. So we really began to realize it was a serious problem by that time. And it arrived on Capitol Hill in 1988. And that's when we all learned about it, 88. Most of us learned about it in 88. So we've known about it for about 33 years and not accomplished a lot with it yet. It's pretty simple explanation. The sun's power is supplied to Earth as ultraviolet and visible radiation. The Earth then emits a portion of that that's not absorbed into the Earth as infrared radiation. And normally that infrared radiation can escape the Earth. And of course, the CO2 has been good over the years, and it kept us without an atmosphere, without CO2 in the atmosphere, it would be very cold. It would be around zero everywhere. So CO2 is necessary, but we've got a lot more of it than we ever had before. Of course, methane is another one of those gases that act as a blanket to warm the Earth. So these gases absorb the infrared radiation rather than let it pass through and heat the Earth that way. Anything that creates these gases contributes to the blanket that warms the atmosphere. We're releasing a lot more of these gases since the Industrial Revolution at an alarming rate. Now this is the Keeling curve we talked about a minute ago. In 1957, Professor Keeling at the Mauna Loa Laboratory established the CO2 monitoring system. And it's been in continuous effect since that time. And you can see the CO2 curve has gone up tremendously. As of 2 days ago, or 3 days ago, I checked, we were at 420.01 parts per million. And historically, the level has been about 260 parts per million. So you see this dramatic increase in carbon dioxide level. As of 2017, these are the last figures I had available. Carbon dioxide constituted 80% of the greenhouse gases, excess greenhouse gases released that year. Methane, 10%. Nitrous oxide, which is another gas that contributes to global warming increase, which it was 6%. And then the fluorinated hydrocarbons were 3%. Now, methane is a potent greenhouse gas. It doesn't stay around as long as carbon dioxide in the air, but it's very potent. Same way with nitrous oxide. It doesn't stay around too many years, but it's very potent. Methane is produced through agricultural practices. It results from leakage from gas wells and blow off oil wells, and leakage through the natural gas system. Nitrous oxide is produced by agricultural practices. What caused a green revolution was use of nitrates as parts of commercial fertilizer. But organisms of the earth release this commercial fertilizer is nitrous oxide. It's a potent greenhouse gas. Of course, fluorinated gases come from refrigerants. And for a while there, we were using the kind of refrigerants that damage the ozone layer. Well, we fixed that in the 90s, and the ozone layers improved. But the refrigerants they use today still cause global warming because they're potent greenhouse gases. Here's carbon dioxide over the last 800,000 years. It's always been between 150 and 300 parts per million for the last 800,000 years. These are taken from ice samples in the Antarctic. And the ice crystal, inside the ice crystals, the gas bubbles are still there, and they've been there for 800,000 years. And we can analyze those over the years. And carbon dating can tell us when the samples were frozen. You can see that since the Industrial Revolution, 1750, we've had an increase, and it's exponential now, and we're up again over 400 parts per million. NASA says every decade since 1960 has clearly been warmer than the decade before. 2019 was the second hottest year ever and the hottest non-El Nino year ever. Now, I got information from 2020 was tied 2016 as the hottest year ever. So 2020 was hotter than 2019, and it was just as hot as 2016. We crossed over the 2-degree threshold, 2 degrees Fahrenheit threshold in 2015, and we're unlikely to go back. NOAA says that 2019 was the second wettest year on record for the lower 48. Of course, NOAA is a National Oceanic and Atmospheric Administration. They're our weather people. For the first year ever, the yearly average temperature for Alaska's reporting stations was above freezing. We're releasing carbon. Each person on Earth is responsible for releasing 11,000 pounds of CO2 into the atmosphere yearly. In the United States, we release about 33 to 35,000 pounds each. So we release about 3 times as much as the average human on Earth. Coal and natural gas still supply about 2/3 of our electricity. Coal and crude oil are about 80% carbon. Natural gas only emits about 60% of the CO2 of coal, as it has more hydrogen. So when it burns, it produces water and CO2, but more water than carbon or crude oil. So it's less likely to elevate the CO2 levels than crude oil, burning crude oil or burning coal, but it's still a significant greenhouse gas producer. Arkansas gets 52% of its electricity from coal and natural gas. So we still, despite the fact that we have the nuclear plant here in Arkansas, we don't have much wind and solar. So we get 52% of our electricity from coal and natural gas. Losing forest is a significant problem, and the dry weight of wood is about 50% carbon. Okay, this is the temperature since 1880 to 2020, and we can see that we have warmed a lot. It continues to go up. And this is several people taking the temperatures. NASA, Hadley Center, NOAA, Berkeley Earth, so several different groups. And they're on pretty good agreement that the Earth is warming rapidly. This is another block illustration of it. And you can see that it continues to rise rapidly. Now, the temperature elevation is not symmetrical across the Earth. It has warmed much more in the Arctic and the Antarctic than it has across much of the Earth. So the Arctic, the Antarctic, and really to some extent the equatorial regions have been the hottest. And of course the equatorial region are hotter anyway, but now they're really hotter. And of course the Sahara Desert's increased a lot in size in the last 50 years. You can see that we're lucky in terms of temperature rise. We here in the Mid-South have had some of the least warming of any place on Earth. Rate of temperature change has been less here, and so we're fortunate in that respect. But we have higher humidities. These higher humidities result in bigger storms, result in higher heat indexes during the day, resulting in warmer nights too. So that even though the temperature total has not gotten that much warmer, the nights have gotten warmer because of the high humidity. NASA predicts change will continue through this century and beyond. Temperature will continue to rise. Frost-free seasons will increase. There'll be more floods, droughts, and heat waves. Hurricanes will become stronger and more intense. Sea level will rise 1 to 4 feet by 2100, and the Arctic will become ice-free in the summer. I took this picture at Athabasca Glacier in 2008. That's near Alberta, Canada. And as you can see in the next picture, I didn't take this picture, but I found it online, and it shows this is where the glacier was in 1908. It was all the way across the road. This is like over a mile and a half to the glacier from here. The glacier's huge, so it's just receded like a mile and a half in 100 years, and that's typical. I've been able to tour a lot of Canada and a lot of Alaska, and everywhere you go, the glaciers have receded remarkably. Arkansas will continue to have larger rainfalls and more flooding, an increase in droughts that could affect river transportation, increased temperatures may lower crop production, and more pines and fewer oaks will be present in the Ozark Mountains. Of course, that's a picture of the historic flooding on the Arkansas River in 2019, in May, I believe that was. We're still 4 feet short of crest there. So, and the guy came out and said that it had gone, the volume of the river had gone over, I see it was 500,000 cubic feet per second that day, the rate of flow, going over 500,000. For Little Rock, 7 of the 10 warmest years on record have been since 1997. 2010 to 2019 was the hottest decade ever recorded. It was 1.2 degrees Fahrenheit higher than the average for the 20th century. All of the 10 coolest years were before 1984. 9 of the 10 snowiest years were prior to 1980. All-time record low was minus 12 degrees, February 12th, 1899. All-time record high was 114 degrees, August 3rd, 2011. And looking at historic records, there were other times that the temperatures got into double-digit minuses in the Little Rock area. In the Civil War, there was some documented temperatures that were around 14 degrees below zero. It's getting wetter and sometimes drier. The all-time 24-hour rainfall record was over 16 inches, and it fell in July of 2019. The all-time annual rainfall record of 101 plus inches fell in 2012. I did an analysis on the average yearly minimum temperatures in Arkansas at 2 stations, at Drakefield and Fayetteville and Adamsfield and Little Rock. I chose those because they've been there a long time and they've had records over a long time. And I found that since '89, that temperatures are climbed, the average minimum winter temperature has climbed 4.3 degrees Fahrenheit at Adamsfield and 6 degrees Fahrenheit at Drakefield and Fayetteville. And this is exemplified by the USDA hardiness zones. This was 1990. Now the colors on these two are different, but I want you to look at this line right here at the bottom of the red, okay? The bottom of the red represents where zone 7 meets zone 8, okay? You can see that it was at the roughly the line between Arkansas, Louisiana, and about half of Mississippi, Alabama, Georgia, and South Carolina. If we go to the 2012, different colors again, but this is where 7 meets 8, okay, where yellow meets orange. You can see that Arkansas is over half of Arkansas is in zone 8 now. Essentially all of Mississippi, Alabama, Georgia, and South Carolina are in zone 8. When this was published, the USDA didn't want to announce it because they were afraid it would frighten people. Any questions on that little part of the discussion?
Larry, can you explain what is what the significance is of that difference of the meeting of zone 7 and 8, like
Okay.
for Arkansas, because I'm not sure exactly the impact
Okay.
that you're
I
speaking
didn't explain
about.
what USDA zones are planting zones, okay? So it tells you when to plant and also hardiness, okay? So it's planting zones and hardiness zones. So if you got a plant that is capable of surviving, say 0 to 10, then it will do and find its own 7. If it's capable of surviving at between 10 and 19 or 10 and 20, it'd be a zone 8 plant, okay? So in the planting times too would correspond to those, you know, the planting times you plant your tomatoes and your frost times would correspond to those zone lines. So that's what the zone lines are. So they're the minimum temperature, okay? So the minimum temperature in Arkansas, where it was previously 0, of course, with the exception of this year, had gone from 0 to +10. So basically, Arkansas had previously zone 7, most of it becomes zone 8. So that represents the average minimum temperature.
There's a person here in the Russellville area who has a blueberry, come pick your own blueberries farm. And he gave a presentation to us at Citizens Climate Lobby at one point and was talking about how when he first moved here and started his farm, he talked to the agriculture extension about what kind of blueberries to plant, and they gave him a suggestion. And then several years later, he had to go replant everything because the blueberries he had been advised to plant could no longer grow well here because of the change in temperature. So that's kind of, I think for me, it gets to like the economic impact of all of this. That was my main takeaway from what you were saying, Larry, is, all these floods, just looking at video coming out of Northwest Arkansas the past few days. I mean, the cost of the road repairs, the cost of these water rescues in terms of dollars and also just impact on people's lives. I mean, I was reading about these students. There weren't many students, but students who were caught on buses. Who wants to get caught on their school bus in the rain? I mean, in a flood, how frightening.
And so many people, Jan, don't have flood insurance. And if they do, there's that little fine print, where oftentimes they can't even collect if they have damage to their home or their, the goods inside their home. And so, and I think, it's sad, but when you bring it down home into economic terms, that's something that really hits home. I think with a lot of people.
Yeah, so, and the impact, the economic impact on our cities that have to repair these roads, or on the counties. Our counties and cities are, have been strapped for cash. What county or city isn't? So who's going to repair all this?
In Arkansas rice growing areas, the University of Arkansas did a study and documented that the overnight temperatures were 5 degrees warmer during the rice growing season, and it was beginning to affect the viability of rice. And they were thinking eventually you're going to have to move to central Missouri to be able to grow rice. So that's kind of scary for them.
Jeannie, I noticed, I remember before we got on the call, you said that you had moved here from Ohio, and I grew up north as well. And I've just been struck by how darn humid it is here at night.
Yes.
And I just figured that was the way it was. But then after meeting with Larry, who has this huge background as a master naturalist and so forth, I realized, it hasn't always been this horrid.
Right. Yes. Bringing it down home again to the economic thing, my electric bill for, like the running of the air conditioning is crazy higher during the summer due to, and it's not just the high temperatures, it's the humidity. Because like I have allergy related asthma. And so like the high humidity affects my breathing, makes it difficult. So I have to keep the air conditioning at a certain point, you know, to keep that moisture out and everything. And so, yes, it's crazy. And the bill is always higher because of the humidity. And
Mhm.
yes,
The allergy season has extended by days because of the change in temperature. Yep.
see, now there's a health impact, you know, so we're talking about economic and health there. So this climate change is not just something out there. I mean, there are other areas that it affects other parts of our lives. And I appreciate y'all bringing that out.
Yeah, it's already happening. And this is kind of just one of those like feel good things. But Larry was telling me, for example, that the Arkansas River used to freeze over. I mean, how cool is that in winter to be able to be like,
Yes.
this is frozen over.
Yeah.
I don't know if I would have ever gone ice skating on it, but still, I guess that doesn't happen anymore.
No, it didn't happen anymore. I don't think it happened this last time during the last cold spell. I don't believe the Arkansas River froze over. I don't think it did.
So
Nope.
that kind of, all these impacts really leads to the question of what are we going to do about it as individuals, as a society? We know there's a lot of more talk in the government now about taking action. President Biden just recently held his Climate Leaders Summit, which I found very encouraging personally. There's a great tool, which I mentioned, that's been created by Climate Interactive, and Larry has trained to become a Climate Interactive ambassador, and actually so has Joe Elskin, who's on this call.
Not yet.
You haven't done your finals yet.
I haven't
Okay.
taken, yeah.
But
Yeah.
I'm gonna put, if I can get my computer to work, I've been having trouble with my internet, but I would like to cut and paste the link to that in the chat. And Larry's gonna share a little bit with us about Climate Interactive, and then we can test it out and test out some different solutions.
Okay, here goes.
Oh, and it looks like someone else joined the call. Stephen.
Yeah, great. Okay. This is the En-ROADS simulator here. This is by Climate Interactive, and it's a simulation model, and it's made with Climate Interactive at MIT Sloan Sustainability Initiative. It's grounded in the best available science on climate impacts and solutions. As you can see, this is the temperature graph, and the business as usual suggests that by the year 2100, we'll be 3.6 degrees centigrade, or about 6.5 degrees Fahrenheit, warmer than we were about 1980, certainly pre-industrial before 1980. So 3.6 degrees, and we'd like to keep that to 1.5 degrees. And currently we're about 1.1 degrees above pre-industrial levels. So if we go back all the way to pre-industrial, we're about 1.1 degrees. So that's about 2 degrees Fahrenheit. So to keep it below 1.5, we're really gonna have to work fast. But anyway, that's the temperature over here. And these are the global sources of primary energy. And they include in brown, coal, in red, oil, in dark blue, gas, in green, renewables, and that includes solar, wind, and hydropower right now. Bioenergy is like burning wood for fuel. And the nuclear is very small. Worldwide is very small, and it's a tiny blue line. And the new zero is that we don't have any new zero carbon source of energy at this time. It'd be great if we did, we don't have any. And this down here represents the sources of CO2 pollution. coal, oil, natural gas, bioenergy. Of course, renewable is not a source of pollution, but here's the energy supply. Nuclear is a non-CO2 emitting source of energy as well. We have the potential of carbon price here that we could utilize in our simulator, and it's down here. Transportation is a major source of CO2 emissions, and we have energy efficiency, electrification that we can work on there. Building as an industry, we have energy efficiency, electrification there, and we have growth in population, economic growth. Then in the land and industry emissions, we have deforestation, which is loss of trees from, like in the Amazon. That's in tropics are the main source now of tree loss. All that carbon goes back in the air. We have methane and other. This would include methane and nitrous oxide, as well as those fluoridated hydrocarbons we talked about earlier in terms of the refrigerants. And then another thing we can have here is carbon removal on our guide here, and afforestation, planting trees, and the technological carbon removal such as carbon capture and storage underground. And those are being worked on now. We don't have any good technological carbon removal yet, but there are many promising solutions coming up with that, and it's being worked on now. So basically, I'd like for somebody to propose, maybe you could write in the chat, and then Jen can read it to me about what you suggest we do as far as things you'd like to see done in terms of these sliders here.
Suggest a solution. You could either unmute since we have a small group, or pop something in the chat.
We should decommission coal production.
You want to decommission coal? Okay, we go here and we decommission coal. We will say, we'll go down here to 100% reduction in coal utilization.
Okay.
That's basically what we're going to do. And we're going to make, you want to start this year, or what year you want to start?
5 years.
5 years, okay.
2026.
Okay. That's where you see a dramatic decrease in coal at that time, because it's going to be totally banned. So it's different, didn't it? Okay. By simply stopping coal production, we saw that the brown here disappeared, but before 2040. We did drop our temperature quite a bit.
And Larry, I like that idea, but I think that if we enact something like that, that there needs to be some sort of like retraining program for people who that's their life work. You know what I'm saying?
Good.
So
yeah.
Because for some people, that's how they support their family. And, so if that is just like completely taken away, you're looking at a lot of people being out of work, and maybe they don't have, like, they've not been trained in other skills, or maybe they don't have a college degree or whatever to be able to just walk out and get another job. So I think that's a great suggestion, but I think hand in hand with that we also need, if the government did something like that, to be able to have some kind of retraining program and to help integrate those people into other jobs so that they don't wind up just like in poverty.
I think we'd all agree, and certainly the model has that information, about the potential equity considerations, and certainly that would be a major problem with stopping coal immediately, and we're assuming it's going to be worldwide too, and a lot of economies totally depend on coal, don't they? I mean, even China most of their energy production is coal.
Yes.
Most of their sources of primary energy are coal, and India as well. And those are developing nations, and they have a tremendous dependency on coal. So, stopping coal, would be a potential problem for them, and a major problem for them. So, but yeah, the equity considerations are in the model here. If you want to take time to look at them, and certainly you are correct in terms of the response that had to be made to, and all these things we're going to assume are going to be worldwide. They have to be global, and it'd be difficult to do. But for this scenario, we're going to stop coal production completely. Anybody else have any comment?
I love the idea of the like electrification, like for electric cars. But
Okay.
my concern in that is that for people who are not as well off economically, being able to afford an electric car.
Okay.
So, I guess you can tell I'm a
Yes.
people person. I really care about what happens to people, but
Oh, sure.
but it concerns me because I've not shopped for one, but I do think that currently the electric and even the hybrid models that are available now are rather expensive, and I don't think I could afford one.
Well, we'll have to have, production in numbers will help that a lot. The battery cost has already come down tremendously over the past 10 years. Originally, if you bought a car that had 60 kilowatts of energy, like I've got a little Bolt, and I think I paid about $32,000 for it after discounts. So it wasn't expensive compared to the previous car I'd gotten. But if you looked at that 10 years ago, and you tried to get 60 kilowatts of power for it, the car would have cost you like $100,000. So that represents the decrease in the cost of the batteries just because of the technological advancements and the volume building of the batteries. So we'll continue to see that improve. Maybe we have to give federal incentives to try to get to electrify as well. But do you want to propose some electrification? Do you want to see what it does?
Sure. Yeah. Let's look at that.
Yeah, if we electrified cars at a moderate amount, it made a difference, didn't it? Okay. And what did it make a difference in?
Made a difference in renewables and gas.
Gas went down, didn't it? And renewables, since now solar and wind power is cheaper, renewables will increase when you go to electric cars. So it did make a difference, didn't it? Okay, so we did electrify, and it's incentivized again. So it might be the government would be continuing to give big rebates. Like on my car, I got a $3,900 rebate. Of course, the taxpayers paid for that, and
It doesn't
appropriate or
electrification,
inappropriate, it helped me.
doesn't electrification also include a public transportation electrification?
It would include, yes, it would include public, electric buses, electric trains, all that sort of thing as well.
Larry, is energy efficiency under transportation, is that like better fuel mileage? Because that's something that's been being talked about right now, is increasing fuel standards. What does that do?
Well, now we've already gone to highly electrified.
Oh, okay. So it's not
it does
gonna be
make a
as big.
difference. It made a difference. So if we highly increase electric energy efficiency of vehicles, even with electrification, it still made a difference. Okay.
I have a question. Does and you briefly touched on it. So I think not Jan, but the other lady here. Forgive me.
Joe.
Joe,
Yeah.
I'm sorry.
Mhm.
Joe mentioned the increase in public transit. I think I've been to seminars and I've done programs with Rock Region Metro, and my daughter is a public transit user because we only have one card. But I would love to see, like bringing it home, like to Little Rock and some of the, major cities in Arkansas. I would love to see there be a better somehow where the money's going to come from, I don't know, but, investment in public transportation, because I think that would also go a long way towards, getting those gases out of the air, decreasing that and that kind of thing.
I agree. That would be part of energy efficiency, would be to increase public transportation. Yes.
But isn't all of the electrification, isn't it still powered by fossil fuels?
Yes, it could be, yes, it could be.
Okay.
No, and it just going to total electrification doesn't reduce it that much because, like you say, a lot of it's powered by fossil fuels because fossil fuels are a competitor for clean fuels for renewables.
Larry, a
Yes.
couple other things I've been hearing about in the news. One would be there's movement towards really dealing with the methane in terms of
Yes.
methane that's escaping from pipelines and gas wells, or sorry, oil wells. What happens if we address methane?
Well, if you address methane, methane is a potent greenhouse gas. And so it does make a difference. And if we have even a moderately reduced, even if you moderately reduce methane and nitrous oxide and refrigerant gases that escape, you made a difference. You can see the difference. It made a big difference.
Okay.
The other thing that we're hearing that I'm seeing a lot of in the news is that talk about carbon pricing or carbon tax. And that's one of the things we focus on with Citizens Climate Lobby, full disclosure. So what does carbon pricing do?
Well, if we go by our plan that we have supported, and is currently on the floor of the House now, there are several bills that relate to carbon pricing, and but this is our bill here. I'll put it in. So we start at $15 a ton with the.
This is the Energy Innovation and Carbon Dividend Act. It's just been reintroduced into Congress. It actually has its own website, the energyinnovationact.org. It's a carbon pricing bill that Larry's modeling it in there. It puts a steadily rising fee on fossil fuels, which is paid by far upstream. It's paid by the fossil fuel companies, and it includes a monthly dividend to American families or Americans. You can read about it more on the website that I put in the chat, and there's the web link for Citizens Climate Lobby.
There you go.
Okay, so we're down to 2.1C. Now we'd already eliminated coal, you see, earlier. It would have had more of an effect if we had coal was being priced on it, but by eliminating coal and then putting taxes on a fee on oil and gas production, we've had dramatic decrease in oil and gas production. We're down to 2.1C of 3.8 degrees Fahrenheit increased by 2100. So we made a dramatic difference already by putting a carbon price on, stopping coal, increasing energy efficiency and electrification in the transport sector. We've moderately affected methane and nitrous oxide, as well as refrigerant gas release. And so we made a big difference. There are any other things you'd like to see what happens when we move the sliders?
I have a friend who just was able to do some energy efficiency things on her home. I actually think her electric company paid for it.
Yes.
That's, you know,
Let's see what happens when we increase.
what
energy
happens if you do
efficiency
that like on a
bill.
building?
It needs to be in industry too,
Oh, in industry too. Okay.
yeah. I mean,
Yeah,
electrification,
buildings and industry. Yeah,
Yeah.
if we do it everywhere,
Yeah.
it makes a difference. We're down to 2 degrees, and so we've done. We need to take a little more carbon out. And there's other ways we could do it. We can look at this.
How about planting some
area here.
trees? Planting
Uh,
some trees, Larry.
Okay, let's call afforestation. We're going to plant trees. We're going to plant up to a lot of trees, pretty high growth trees. Now, it didn't make a lot of difference, did it, to plant trees? But we didn't see a lot of difference.
and it also took away cropland, which, yeah. So there's a balance needed for trees and cropland.
Correct. It made a little difference, 0.1 degrees. So we have again, they're like you say, there are equity considerations with that, and we can see that, and they talk about those too. Co-benefits, there's co-benefits and there's equity considerations, both.
Larry, what would be some examples?
To planting trees.
Larry, what would be some examples?
I'm sorry.
I'm sorry. What would on carbon renewal? What would be some examples of the technological? What would be examples of that, of ways that can be done?
Yes, the main one would be direct air carbon removal, and there's several. They're doing a lot of research on that now. And basically, they take the carbon out of the air in a machine that concentrates it, and then they inject it deep in the earth, and like where they've done fracking, and they inject it deep into the earth, and the carbon then is crystallized on like basalt deep in the earth, and it is stored there permanently because it makes the crystals. And there's quite a bit of work that's been done with a direct air carbon removal, and that's one way. The other way is to catch carbon coming out of smokestacks, and then to make it into chemicals that we can use. They can make plastics out of it. They can make it into chemicals that are used to make jet fuels and things like that. So they can capture carbon directly out of the smokestack as well. So there's 2 ways that they can capture carbon. So let's see what we do if we add some technological. Let's put it to medium growth and look at that.
Wow.
Even medium growth, we got down to 1.7 degrees centigrade. So we made a big. And anything else you want to work on to see what happens?
Electrification of buildings and industry. It won't make a big difference.
Okay. Let's highly incentivize it. We did make some progress, didn't we?
Yeah.
We went down to 1.6 degrees.
How about stopping cutting down the Amazon
Let's do that. Let's stop cutting down the Amazon.
and other places as well?
Look at that. What have we done?
Borneo. Oh, we're at 1.5.
We're at 1.5, folks. We have made it to 1.5. We have to congratulate ourselves.
Yes.
That's big if you make it to 1.5. So we made it.
You know what this leaves me with, Larry, is this thought that so many things have to happen for us to be able to preserve a livable world.
Correct.
There's a lot of equity considerations,
That's
which
the
I think Jeannie really
issue.
spoke to. And then there's just a lot of policy and innovation and application decisions by industry, by individuals,
If
by
it-
the government.
Correct. So much has to be done. And I think that this administration realizes that, you know, they know it's going to be a major effort. So yeah, anybody wants to get a screenshot of that and send it to their friends, they're welcome to.
But you know, I do find it encouraging, Larry, that, you know, because I think so often, I think perhaps one reason why people might, you know, push away from a conversation about climate change is because it's just like one more area of bad news in the midst of a lot of other bad news in our world. And, you know, seeing this and hearing you talk about it, I think is hopeful, you know, to see that, you know, that there are actually things that we can do. Like you said, you know, being able to get it down to 1.5 from where it was, that's significant, and that would have big effects on, you know, the weather, the planting, all of that.
Yeah, it's you know, climate change is going to be devastating, you know, for our kids and grandkids especially, and it's got to be, we got to tackle it, you know.
Yep. Even the 3.6 degrees that it's going to be warmer is going to be scary for my grandson who loves soccer, and he'll play 2 games a day. You know.
Yeah, when that heat index gets up over 95, it gets rough, doesn't it?
Yeah. Yep. Dangerous. Yep.
That kind of takes me back to your original quotes, Larry, that the antidote to despair is action. And also, we can't wait for someone else to do something. There's something that all of us can do. And Jeannie, one of the things I think you'll love about Katharine Hayhoe, who we were talking about earlier, is she says the best thing that we can do about climate change, the most powerful thing we can do is talk about it.
Talk about it.
Talk about it.
Yes, and that's why I was so thrilled to have you all here. And, you know, the library is just thrilled to host you all. And, you know, the turnout tonight was okay, but, you know, there's a lot of competition out there for what people do in their evenings. But the good news is that we are recording this, and it'll be uploaded to our Cal's YouTube channel, where, you know, people can view that. And so when we get it, when we get that link posted, I will send that, Jan, to you and Larry, so that if you'd like to share that around with any of
And me too.
Okay.
I'll send it to you, Joe.
Yeah. I happen to have Jan and Larry's because they've been my contact people for the program, but I'll make sure that the video link gets shared. And that way, if you'd like to share it with, you know, other folks, you know, because I think the first step to change also is awareness, you know, because if their head is in the sand, or they think, oh, this is nothing, you know, it's easy to just brush it off. So I think step one is awareness. And then, you know, then you can begin to look at how you can take action.
Yeah.
So,
and like you said, there's many problems in the world. And at the same time, if we acknowledge there's a problem and we can all work together, there's so many people in Arkansas and in this nation and around the world who want to tackle the problem of climate change and who are working on it. And together we can make things happen. Jeannie, you've been so great to work with. And again, kudos to the library system for offering a whole month of environmental, earth-friendly, climate-friendly programming. Bravo.
Thank you. It was great.
Yeah.
Well, you all did a super job. And I just want to thank you again for coming. And it's been great to have you. I'm going to stop the recording. So give me just a second. I'm not seeing it. Okay, here we go. They've changed it.